Hi guys, this is Ujjwalify, and today I'll be covering the AR and MA models, which is statistical models. They are traditional models, but uh, we are continuing this traditional models as we have previously discussed about the smoothings, halt winters. We have stopped into the halts winter, but now we are here to continue the AR and MA models for today. And later on, we'll discuss more about the ARIMA and other model which works on all the fluctuation seasonality trends. Yes, let's start without any further ado. What actually is AR model is predict future based on linear combinations of past values of the same time series. Assume the series is stationary. Yeah. The AR models predict the future value based on the past values. Like we have, let's say we have the sales data, and I think here ChatGPT had generated one sales data. Let me show you. Yeah, okay. Let's see it. Here is our sales data, and like let's not like don't see here. It is not actually. We are just considering date expected sales, uh, and this one. Okay, let's not also take this example. I don't have any other example. Okay, let's say yeah. If you have to predict the next future values, future sales, then the MA model, how the MA model works is like it use previous value and added some weights on them and predict the future values, which is just like a linear regression. Here I have the equations for the AR models and forecast equations also. It's as same like linear regressions I already told. Uh, Here is one constants and phi 1, phi 2, phi 3 and phi p. And these all are the weights given to the past values. uh, how the weights at the actually we have already discussed about the weighting averages, and that is how the weights are assigned to the past values. And we have these equations and used to predict used to forecast and the sales value. For now, let's uh, only stick into the sales data. Will In this video we'll only discuss about the sales data as an example for AR and MA models. First of all, we should have the order, like P stands for order for the AR models. That P comes from the PACF, which is the partial autocorrelation functions, and which determine the value of P. Like uh, this PACF calculates the correlations between the current values and uh, the observations with which we want to calculate the correlations directly. Yeah. From that, the P value of P comes in, and we can find the value of YT, which is the current observations, and further on we can forecast the value based on the weights and based on the order for the AR models. Yeah, that's all about the AR models. And what actually PACF and ACF is, I have mentioned here, that is statistical to measure the correlation between time series and its own past values. Like time series, let's say as in y, and the we actually say the past values as a lag, and that's is the notations for the past values. Yeah. For the AMA models, there is a bit different from the AR, because AMA model is more relied on the errors rather than the past values. The residuals are contributing in the AMA model, so that it is uh, different from the AR models. AR models actually looks for the long-term memory, but MA doesn't. MA works on the short-term shocks uh, and random shocks. Like here I have the here I have added the definitions for this random shocks. And yeah. One thing similarity between the AR and MA is they both work on the perform the modeling on the stationarity time series. Like they doesn't consider the seasonality fluctuations and other components like trends in the time series. Uh, Yeah, that's all about the AR models. AR models is not more difficult. The weights are generally calculated. We need the weights uh, for the uh, to find the value of y t, and the weights is generally like an OLS, but we can say OLS that the weights are different. Like for the YT, the weights is more than the phi1, the value of phi1 is more than phi2, and so on. For the value is for the value for the phi p is less then the phi 1, so the weights decreases on the going back to the past values. So yeah, we have an one white noise. What we I think we say, yeah, white noise. Here is that is an random error added, like it is just like a error in the linear regression. We used to add one random error into the equations, and as same as here also. So yeah, AR model doesn't consider the error to predict to forecast the values, but MA does. AR actually, the full form of AR is auto-regressive models, and the MA is moving average. Uh, Now let's get into the MA model, like moving average models. I have already said about it more rely on the error rather than the past values. The Q is an order for the MA model. Uh, yeah, the Q is actually calculated, can be find by ACF, which is autocorrelation functions, and we already discussed about ACF and PACF in the previous videos, I think. And here we have two different non-linear terms in the moving average. Like either we have the weights and the error of the past values, and based on that we predict the we predict the time series. So yeah, here in my I have drawn Venn diagram. Here I have past error rather than the past value. That current value is current value depend on the past error. Like from the past error, it predict the current values. And I have its plot also. Here you have this is the plot from the AR models. Like this green one is AR forecasting. I have said that they doesn't work on the seasonality fluctuations. So yeah, the line is linear and which is not overlapping with the orange one. I mean, not synchronized with them, because these all are the like trend seasonality. But we know that AR and MA model doesn't work on the uh, where it going. Uh, yeah, this is the prediction made by the AR models, and I have the AMA forecast also. This is another forecast of AMA models made by the AMA models. Here it is sharp falls, and but here is a smooth one, because the errors is the error doesn't error gradually falls due to the short-term shocks. Like uh, in the sales data, suppose the error was more like the prediction made by the AMA. Let's say the prediction made by the AMA was is 110 for today, and actually the actual value is like 150. That is what actually the high rise in the uh, in between in the cells, and the difference between them is so high. That is that what actually is the residuals. And in the next day the cells doesn't remain same. Like from the 180, like the increase in cells is like the difference previously today, let's say yesterday, the cells the difference between the actual cells and the predicted cells is 40 units, and in next day, like today, the difference is, let's say, the residuals between the and the difference between the actual value and predicted value is just 20. That means it falls more gradually, like falls 20 unit drastically, and that's how it affect into the forecasting. I have one example here. I think I had the ChatGPT gave me. Uh, yes, I have given from the where it was. GPT gave me a nice example. Like uh, let's. I think this is not the actual one, but yeah, yeah. I think this is uh, 018 and not this one. That previous one was the example I was talking about. Expected sales was 100 and actual sales was 100. This is not a noise. Noise means that shock. Shock means the no. Yeah, no. We generally say noise. Like here in the charts, and let's say this is a noise. Not let's say, but it is actually is noise. Like this one also. Yeah. 102 and in difference between the 102 expected sales was 102 and the actual was 100. Big is a positive shock. Like the difference between the actual and predicted is so high. And after then, look at this. if expected sales was 101 and the actual sales was 45, which has dropped so much, like the difference between them is so high, like big drop there. And how here, suppose let's say, considering these equations, at first, like yt equals, let's constant, give constant c itself, and let's give the weight, let's I1 equals to 0.7, let's give it, okay, 0.7, and let's say what is the difference between them, uh, 78, yeah, 78, okay. What c plus, what is the product, okay, let's calculate it. It is like 54.6, and consider it as an okay, c as an 1, okay, 54.6, which is 55.6, and if the difference between, like, okay, and let's go into the date 3. The actual expected sales was 101 and the actual sales is 45. The difference between them is how much? 150, 50, that's 56, yeah, 56, and with the same weights, c plus 0.7 into 56, which is 1 plus how much? Actually it will come lesser than this one, no? Okay, let's calculate. This is 39.2, this is 40.2. Look at the difference between them. Like, if we plot the chart and the, let's, and if the 56 is here and 40 it comes to here, look, it rises sharply, and if it comes like from, let's say, in another day comes like this, like this, like this, and goes on, but actually it doesn't follow the path, it goes straight. Considering this one, it will do, but in this case it won't, yeah. That's how the moving average work. And here another main thing I want to discuss is like the error, how they, firstly the error are generally calculated from the previous data we have, the past values we all have in the data sets, and the coefficients is randomly given, that is weights given to the each past values based on the what we can say that the recent observations are assigned of more weights rather than the older one. So yeah, that's all about the AR and MA models, and later on we'll more discuss about the AR, MA and ARIMA models, and then we have another SORIMA and SORIMAX also there. This much for now, this much for today. Here I have also added the heuristics term that I didn't know the meaning of the heuristics, but now I know. Rule of thumb, that means sort to find the solution quickly. It is like tips and tricks while solving the MCQs. That was the meaning of heuristic, but I didn't know previously. Okay, this much for today. The random shocks, like what actually is random shocks means, the sudden change. Like one major things between the AR and MA is AR looks for the long term, like it doesn't consider the moving average effect. What actually moving average effect is, like the short term shocks, like the highly fluctuations, like in the chart. Let's consider that if this was a chart, then it down the sales data are gradually, and the sales decrease falls so much in short term, like, and which is not captured by the AR models, but the MA models come to overcome that problem. Like MA models capture the short terms uh, shocks, and but AR doesn't. And they have their advantage on their own field. Like AM work for the long terms, and which doesn't work for the trends and fluctuations, but C for the long terms. It models the long terms one, but MA works on the short terms data, short term stocks. Like I think I have here. Yeah, that is they have their own limitations. Like AR models doesn't account for the moving average effect or seasonalities, and the moving average also have the drawbacks, where it was it doesn't capture long term dependency or seasonality. Yeah. Long term dependencies means it doesn't consider the long term. Like let's again discuss in the sales data. Like talking about the 1 month data. Like the MA can works and can captures the trend, capture the uh, what we can say shocks of about in between the a month happened, but doesn't can't capture the long terms. That is, let's say, let's consider often the yearly sales data. It doesn't work for that. Like in the suppose in last December, the sales of the Santa Claus dress is high, and now it's like zero, almost zero. And the MA models doesn't consider the high sales of the last December, but the AR model do. Yeah, so that is the main difference between AR and MA. And graph is also difference. Like here is that the smoothly they have went down, but the gradual change in the MA plot, that is also another major. This is due to that AR model doesn't consider as error to predict the future values, but MA do. So the AR models takes the previous uh, past values for the predictions, for the forecasting, but MA doesn't. That's how the graph are also different. Anything left? I think not. Yeah, this is the forecasting equations, and this last term is random error. That is white error. We say white noise or error. We say, and we can see from the equation that the AR model is more relied with the previous older values. And here is our the MA model equations. That look at here: E t minus 2, E t minus q. Why the okay, let's not say. Okay, that's all for today. Let's end this here.